We are the Flying Dutchman, and this is our NC State FEDD project, Precision Launcher.
During our project design, we implemented the steps of the engineering design cycle. First, we asked what our design requirements were and how we would be able to get the most points in our competition. And we realized that repeatability and precision were the most important. We imagined different designs and researched prior FEDD launchers for our project inspiration. We decided to try to use as many found and reused components as possible to reduce the amount of time it would take us to get our materials. After that, we made a plan to construct and test our launcher, and with a few delays assembled it by the design day.
Our final product ended up being an air-powered launcher on a stand, but it didn't start out this way. Our first iteration was just a PVC pipe connected to a 2-liter bottle, which was easily able to shoot our projectile far enough, but was not very accurate.
Challenges we faced were getting the correct angle to shoot the projectile. To combat this issue, we put pegs into a PVC pipe so that the neck of the bottle could rest on it. The pegs were spaced at a specific distance so that moving up one peg was the minimum amount that the system would support. This means the angle changes were very slight and precisely measured. At the final presentation during FEDD Day, we took first place in our session. We believe we could have scored higher after reflecting on our performance. Our launcher had some issues with accuracy, even though it was a stress in our design.
If we had to do it over again, we would start earlier and test more often. It wasn't until a couple of days before FEDD that we had to put the final touches on our launcher. We tested our launcher at Cram and Jam with the test target that resembled a similar one to that on test day. By this time, it was the day before FEDD and we felt pretty confident in our design because it had power and launched relatively consistent. The only problem was that our accuracy was lacking, as experienced on FEDD Day. If we had to do it over again, we would set aside more time to test, analyze, and adjust our project such that there were no expected problems that we would encounter.
For future engineering freshmen, we'd like to emphasize the importance of making and keeping a detailed plan and schedule. Do this before anything else in your project, and don't take delays lightly. Too many delays could put your whole project in jeopardy.
We hoped to have more iteration cycles, but unfortunately we ran out of time. This highlights the importance of sticking to your original schedule as much as possible. Testing your project is a key component to succeeding at FEDD Day. Your delays will reduce the quality of your final project as you will be less able to improve your design.
From our research, we knew what would work best. These were the sources we used to help us determine the most effective project.